Assalamualaikum warahmatullahi wabarakatuh and good evening or good morning to everybody. All right, so this is week 11. Week 11. So today I have to do the offline class session, recorded class session where I'm going to discuss a little bit about Laplace tutorial, which is tutorial 3. So we have discussed last week about tutorial 3, question number 1 and 2, if I'm not mistaken. So I think today I'm going to continue with question 3, 4, and 5. Hopefully I can cover all this within maybe less than 1 hour. So that after that, because I want students to do assignment. Okay, I already opened the link in ULearn where you have to submit today, okay, by 15 December, assignment regarding chapter 3, Laplace. What you have to do is to complete, listen to the video recording that I'm doing right now, try to understand, and then you can, I think, by following or by watching my video, I think you are able to answer assignment 1, assignment 1, chapter 3, and you have to submit it by before 12, before 12 on 15 December. So it is a group discussion. It is a group assignment where you have to submit in group, not individual. So one group, 3 students. Okay, so we have discussed this, question 1 and question 2. Now what we are going to do is question 3. All right, look at here. Question 3. So before we do, all right, focus on question 3. Before we do, Laplace is very simple, where we know that Laplace is a tool where we can convert from time domain to S domain. So when we have circuits are given to you, what you have to do is to convert everything to S domain. Once you have converted all to S domain, then you can use whatever analysis in order to solve the circuit. Whether node analysis, mesh analysis, Ohm's law, whatever analysis, as long as it is not mentioned or stated specifically in the question. If the question asks you specific method, then you have to use that specific method. Okay, let's say we have this question here, question number 3. Okay, I think it's better for me to open my PowerPoint first. All right. So I need to make sure that I already recorded. Okay, so recording. All right, let's say we have this, then we try to make solution of the this one, right? Okay. Pages that we can solve that. All right, so here we are. So when we have question, as I said, you need to know Laplace transformation. Laplace is to convert from time domain to S domain. So we refer back to the question that we have. So this is the question. You have 75 exponential minus 2t ut, and then you have 1 ohm. You have 2 Henry, you have 2 ohm. And for this question, 0 initial condition. Okay, because IL in bracket 0 is 0. So you don't have to consider the initial condition because initial condition is 0. We don't have capacitor. What we have here is only inductor. So here we are. Here is the circuit. So convert everything. All the components here must be converted to S domain. All right. So first of all, you have to draw. Okay. Draw the circuit in S domain. Okay. I have the voltage source here, right? And then I have 1 ohm. And then I have 1 inductor. And then I have ohm. All right. So 2 ohm is still 2 ohm in S domain. 1 ohm resistor is still 1 ohm in S domain. All right. Initially, you have 75 exponential minus 2t ut. Right. So if you convert this to S domain, you are going to have 75 over S plus 2. Right. And then okay, you can see clear. Okay, and then you have here what is it? Inductor value is 2. Okay. 2 Henry, when you convert to S domain, it will be LS. So 2 times S, 2S. I think that's all. And then the question asks you, what the question asks you? Find V naught T. So where is V naught T? Here is the V naught T. V naught T is the voltage across the 2 ohm resistor. All right, we need to understand that first. So V naught is here. Okay, voltage across the 2 ohm resistor, right? And this voltage, because it is parallel, it is also the same voltage across the 2S inductor. All right. And the question, okay, the question not mentioning about any specific method to be used, but let's say I would like to use node analysis. Perhaps later on you can compare. Let's say you use mesh analysis. The answer should be the same. All right. Let's say I want to use the node analysis. Okay. Remember that before we do any analysis using the node analysis, what you have to do, you need to label all the nodes. Here I have the nodes here at this point here. Let's say this is V node. All right. And then I must also label all the current. Let's say this is the current in this branch. I label it as I1. And then the current here, I label it as I2. Right. And then the current to the right here, I label it as I3. Okay, that's it. So using the node analysis, using node analysis, okay, I have to get the KCL, Kirchhoff current law at node B node. So Kirchhoff current law says the current in is equal to current out, I2 plus I3. So this is Kirchhoff current law. So everybody should already familiar with Kirchhoff current law. This is actually KCL, KCL, Kirchhoff current law. Current in equal to current out. All right. So what is your I1? I need to get in terms of the voltage. Okay, using the Ohm's law, I1 is the current that flow from this point here to point V node. Okay, there is no other component at the other uh, connection here. So it is actually between this node here to this node. So I1 is actually 75 over S plus 2, which is the voltage that already converted to S domain, minus V naught divide with 1 ohm. This is I1 equal to I2. What is your I2? Where is I2? I2 is between V naught and the reference node. The earthing here is actually the reference node, or this is actually 0. Okay, so your I2 is V naught minus 0 divided with 2S. Ohm's law, this is Ohm. Plus I3. What is your I3? I3 is V naught minus, V naught minus 0. V naught minus 0, because this is the reference point, point 0, divide with 2. Only 2, not 2S, only 2. This is I3. Current flowing in I3 branch. So you need to simplify this equation. Try to arrange this equation, make it okay, proper. So here I have 75 over S plus 2, okay, minus V naught equal to V naught over 2S. I just rewrite, plus V naught over 2. Right? So now what we can do is we try to put V naught at one side. Okay, try to put V naught at one side. So let's say I bring this V naught to here, okay, and make 75 over S plus 2 on the other side. So what we have is V naught plus V naught over 2S plus V naught over 2 equal to 75 over S plus 2. All right. So I can factorize, make V naught outside, and inside here I have 1 plus 1 over 2S plus 1 over 2. So to 75 over S plus 2. All right. And then simplify the inner, the bracket here. What you have is V naught in bracket. Okay, 1 and 1 over 2. Going to be 3 over 2. Okay, plus 1 over 2S. And this is equal to 75 over S plus 2. All right. And then, all right, we know, so inside there, we make it 4x at the bottom here. So you will have here 6s plus 2. Yeah, because if you simplify here, again we have 3 over 2. 3 over 2 plus 1 over 2s. Okay, so here in the bracket now, 6s plus 2 over 4s equal to 75 over S plus 2. All right. So what is your V naught? So bring the rest to the right hand side. Initially we have 75 over S plus 2. Right. So it's going to be times with 4S over 6S plus 2. Okay. So can we simplify that? Can you simplify this? Let's say I want to take 1 over 6 out. Maybe I can write down like here, 75 over S plus 2. And then I take out 1 over 6 out of the inner bracket here. So you will have 4s over s plus uh, what is going to be 1 over 3, isn't it? Because if you uh, multiply again with 1 over 6, then here you have 6 over 3, which is 2. You get this. Okay. Right. So s plus 6 over 3 will be 2. Okay. So I think this is correct because I take out 1 over 6. I take out 1 over 6. And then I can simplify this. 2 times 2. 2 times 3. Okay. And then 3 times 1 with this one, 25. Because 3 times 25 is 75. Okay, agree with that? 75. I think it's correct. So this is equal to 25 times 2 is 50. Divide with, at the bottom, what we have here, s plus 2. Okay. And then the other part is s plus 1 over 3. All right. So this is my V naught that I have right now in S domain. This is V naught. V naught. Okay. So what you have to do right now, I need to simplify, or I need to convert. I need to convert this. This is the answer, V naught in S domain. But I have to convert this to time domain. Before you can convert that, you need to use partial fraction. Okay, so let's do that. Let's write down first our equation. V naught just now equal to 50s over s plus 2 s plus 1 over 3. Okay, so using partial fraction expansion. So this 50s over s plus 2 s plus 1 over 3 is equal to a over s plus 2 plus b over s plus 1 over 3. Perhaps I can be a little bit quick because I think everybody already know partial fraction expansion. So based on this, we can make a comparison where 50s is equal to a s plus 1 over 3 plus b times s plus. Okay, so this is the upper part that we can compare, because this 50s equal to a times with s plus 1 over 3 plus b in bracket s plus 2. This is not new. This is partial fraction expansion. And then you can put in any values you want in order to get a and b. So let's say I replace s equal to minus 1 over 3. So I know that if I put s equal to minus 1 over 3, then this part here, a will be gone. Okay, your a will be gone. Okay, so what left is only 50 times with minus 1 over 3 equal to b minus 1 over 3 plus 2. Okay, so simplify this. We have b5 over 3, because this 2 becomes 6. 6 over 3, 6 minus 1 is 5. So it is 5 over 3b equal to minus 50 over 3. So what is your b? Your b will be minus 50 over 3 times 3 over 5. Cancel. B is minus 10. Right? So you can put in here the value of b, which is minus 10. Now I want to get my a. So what is the value that I can put in? You can put in the value with s equal to minus 2. Because if I put s equal to minus 2, then b will be gone. Alright, so 50 times minus 2 equal to a in bracket minus 2 plus 1 over 3. Okay, you can simplify this to a in bracket minus 6 plus 1 over 3 equal to 50 times minus 2, minus 100. Minus 100. So, a in bracket minus 5 over 3 equal to minus 100. So, your a is 100 times 3 over 5. Times 3. Oh, we have minus. So, minus will be cancelled out. Minus 100 times 3 over 5. And we have minus here. Okay, so minus will be gone. Because both sides negative, and it becomes positive. Alright, so this negative is gone. 1, 2, 0, and a equal to 60. Okay, put in here a equal to 60. Okay, 60. So write again. I can write again. This is equal to 60 over s plus 2 minus 10 over s plus 1 over 3. So can you refer to the table, Laplace table, inversion, back to time domain? So I think you can refer to the table, and this is actually in time domain is going to be 60 exponential minus 2t. Okay. We have minus, minus 10 exponential minus 1 over 3 t ut. All right. So this is the answer for question number 3. Okay. Everybody clear with that? So question 3 already solved. Okay, we solved this. And the method that we chose is node analysis. You are free to choose other method as well, mesh analysis or other methods, but your answer must be similar or same with it, the one that I already solved using node analysis. So this is the answer, 60 exponential minus 2t minus 10 exponential minus 1 over 3t ut. And don't forget volt. The unit is volt. So here, don't forget the unit is volt. Right. So that is the answer. 60 t exponential minus 2t minus 10 exponential minus 1 over 3 t ut. All right. Solve. Just solve question number 2. Question number 3. Sorry. So now we move to question number 4. All right. So question number 4. Okay. I still okay. Still recording. Already 25 minutes for one question. So maybe we have around 50 1 hour, perhaps 1 to 1.5. Okay. So here, all right. So in the circuit below, find the value of the voltage across the capacitor, assuming that the value of the VST, okay, the supply is given 10 UT. Supply here is given 10 UT, and assume that at t equal to 0 second, minus 1A flows through the inductor, and 5 volt is across the capacitor. Okay, so what is the meaning of this statement here? When t0, that means initial value is given. This is actually the initial value. So this initial value is equal to minus 1 ampere at the inductor. Okay, and then 5 volt at the capacitor. Okay, so these are two initial values which is given for the inductor and the capacitor. So it is quite tricky here because usually all the previous examples we don't have the initial value, but now you have the initial value, so you need to refer back to the lecture note. Let me open the lecture note for Laplace. Let me see that. Laplace. So which one? This one. Okay. Here. This is zero initial condition. But for question number 4, we have initial condition. So when we have initial condition, as you can see here, for inductor, it will be either using voltage source or using current source. It's up to you. You can choose this B or you can choose C. So here I decided to use maybe C. I think I want to use C. Okay, we have minus 1. The initial current is minus 1 ampere. And then for the capacitor, you can choose either this picture or this. But I think I want to choose this C. So we have the initial voltage, and the initial voltage is given 5 volts. So this V naught is 5 volts. So it's going to be 5 over S. All right. So let's draw together. So first of all, I have to draw. Here I have the voltage source. And then I have resistor. I have the inductor. Okay, because I just now I decided the initial current for the inductor, I will have picture like this. Okay, and then for the capacitor, I decided that I want to choose the initial voltage of the capacitor. I will have this 5 over S. Your capacitor, what is the value of your capacitor? 0.1 farad. So 1 over CS, 1 over 0.1. So 1 over 0.1 is 10. So when we convert to S domain, 10 over S. What about our inductor? Let's check here. We have 5 Henry. So 5 Henry is going to be 5S. And initial current, we have minus 1 ampere. Minus 1 ampere, and we choose this. So it's going to be minus 1 over S. So it's going to be minus 1 over S. What about resistor? 10 over 3. So resistor here maintain as it is. 10 over 3. 10 over 3. And then the supply is 10 over S. Okay, 10 over S. Because Gs is 10 UT, so So it's going to be 10 over S. That's it. All right. So which method I want to use? Mention, no specific method. So again, I like to choose node analysis. So if you want to choose node analysis, you have to label all the current and you have to label all the nodes. Here, let's say I label the nodes above here as V1. Here is V1. And then I have to label all the currents. Let's say I label here to the left, this is I1. And then one current down here, this is I2. And then this is, let's say, I3. And then let's see here, this is I4. Right. So applying the KCL, Kirchhoff current law. Okay, everybody know the current in equal to current out. So there is no current in. Everything is current out. So I1 plus I2 plus I3 plus I4 equal to current in, which is 0. All right. So what is your I1? Your I1. My I1 is the current that flow between this node to this supply here, and you have to divide with the impedance here is 10 over 2. My I1 is V1 minus 10 over S divide with 10 over 3. My I2, what is my I2? I2 is V1 minus reference here, Irving is here. V1 minus 0, V1 minus 0 over 5S. Ohm's law, Ohm's law. Plus I3. Okay, so plus I3. I3 is the current, which is minus 1 over S. This is current, because you can see from the shape here, this is current source. Plus I3, your I3 is minus 1 over S. Plus I4. And your I4 is V1 minus, because it is between this node and this node of the voltage source here. So V1 minus 5 over S divided with 10 over S equal to 0. All right. So this is the Kcl equation. As you can see here, we have only one unknown parameter, which is V1. So I can get what is the value of my V1. Before that, we need to know what the question asks us. Find the value of the voltage across the capacitor. So that is the V1 here, voltage across the capacitor. So this is the V1 that we labeled just now. So if I know what is my V1, that is the value of voltage across the capacitor, and the same voltage across the 5 ohm inductor, because it is parallel. All right, now your task is to simplify this. Simplify this equation. Okay, so V1 S minus 10 over S, okay, over 10 divided with 3, so I can times 3 over 10. Same thing, isn't it? So I make a bracket here. This is actually the first part here. Okay, and then plus V1 over 5S minus 1 over S plus, okay, now this part here. Okay, so V1S minus 5 over S divide with 10 over S, or I can times with S over 10. Same thing, isn't it? If you divide with 10 over s, it will be times s over 10. So we can cancel out this. We can cancel that s with s. This is equal to 0. Okay, continue here. Continue here. All right. So what else we can simplify? So this 3 I will multiply in. So 3 over 10. 3 over 10 V1 because S can be cancelled out. So it becomes 3 over 10 V1 S already gone. Okay, minus 10 over S. 10 over S times with 3 over 10. Okay, this is the inner part just now. I can cancel out this. Okay, and then plus with V1 over 5S. V1 over 5S. And then minus 1 over S. Minus 1 over S. Okay, and then the right hand side there, it has plus V1S over 10. V1, okay, multiply this 1 over 10 here. This is 1 over 10, multiply in. V1S over 10. V1S over 10. Minus 5 over 10 is 1 over 2. Minus 1 over 2 equal to 0. Perhaps if you can't see small, maybe you can listen to my explanation. All right. So we try to gather V1 at one side. Where is V1? I have 3 over 10 V1 plus V1 over 5S plus where else? Plus V1S over 10. Okay. Okay. That's all V1 that I have. Okay. This one V1, V1, and this is V1. Okay. The rest equal to bring to the right hand side. Okay, 3 over S minus 3 over S. We bring to the right hand side becomes positive. 3 over S plus 1 over S. Okay. Plus 1 over 2. Right? So I want to factorize V1 outside. So the inner part here, I have 3 over 10. Okay, plus 1 over 5S plus S over 10 equal to here 3 over S, 1 over S. So it becomes 4 over S plus 1 over 2. Alright? Okay, so it looks good. Now, what I want to do, inside the bracket here, make it 50S. 50S. So the first part here, 3, it becomes 15S. Okay, 5, 3, 5, 10. 5, 3, 10, 5, 10. I think that's okay. Plus 10 S. And okay, so that's true. Plus here it should be 5S squared. Because if I cancel out S with S, 5, 1, 10, it will be S over 10. Okay, this is true. Equal to, let's say at the bottom here, I want to have 2S. So here I have 8 plus s. S cancel out, will be 1 over 2. Okay. 8 plus s over 2. I think this is true. You can double check if I have error somewhere. Let me know. Okay, now you can because I want to know only V1. I want to get only V1. So my V1, so you can bring the rest of it to the right hand side. So I have 8 plus s over 2s initially times with 50s divide with 15s plus 10 plus 5s squared. So cancel what you can cancel. Simplify this. I can cancel, for example, s, cancel that. And then I cancel 2 with 25. Okay, and then what else we can cancel? That's it. Okay, so we rewrite it. So my V1 is 8 plus S, some bracket here, and here we have 25 over, arrange 5s squared first, 5s squared plus 15s plus 10. Okay, so this is your V1. This is your V1, but this is V1. Okay, this is V1 in S domain. But we want to know what is V1 in time domain. So your challenge is now to convert. You need to convert this 8 plus S times with 25 over 5s squared plus 15s plus 10 to, correct? Let me check first. Okay. Okay. Oh, actually, this can be simplified further, isn't it? Because 5 here, 5 can be simplified. 5 times 5, 5, and then this becomes 3, and this becomes 2. 5. Okay. That looks good. S squared plus 3s plus 2. At the bottom, the top we have 5. So 5 over s squared plus 3s plus 2. Okay, so we rewrite it again. Let's move to another page. We rewrite again. Now we have 8 plus s. Our V1 is 8 plus s times with 5 over, okay, s squared plus 3s plus 2. Okay, times with 5 over s squared plus 3s plus 2. Okay, so if I multiply this in, what I have is 40 plus 5s over this s squared plus 3s plus 2 can be factorized or not? I think we can, right? So this bottom part here we can factorize, isn't it? It becomes s plus 1, s plus 2. S times s squared, s, 2s, 3s, 2. I think okay. We can factorize that. So this is V1 in S domain, and how to convert to time domain. So again, we use partial fraction extension. So partial fraction expansion, I can be a little bit quick, where it becomes A over S plus 1 plus B over S plus 2. Okay, and then we can make comparison where your above part is A S plus 2 plus B S plus 1 equal to the upper part here, 4T plus 5S. So this is our statement for equation, and you can replace whatever value of S inside here in order to get what is your A and your B. So we choose S equal to minus 2 first because we can cancel out A. So your B becomes minus 2 plus 1 equal to 40 plus 5 times with minus 2. So B minus 1 equal to 40 minus 10. So your minus B equal to 30. So your B is minus 30. This is one value. So I already know here my B is minus 30. Right. So another value of S, I can choose S equal to minus 1. Because if I choose minus 1, then B will be gone. A minus 1 plus 2 is equal to 40 plus 5 times with minus 1. Okay. So A is equal to 40 minus 5, which is 35. So my A is known here, which is 35. So we just rewrite this 35 over S plus 1 minus 30 over S plus 2. And I think this is very familiar, where you can check the table. And this is actually in time domain. So your V1t is 35 exponential minus t, because your A is 1, minus t. Okay, minus t minus 30 exponential minus 2, 2t ut volt. Don't forget the unit is volt. All right. So that is the answer. Let's check. 5 exponential minus t minus 30 exponential minus 2t ut volt. All right. So that is the answer. Okay. So question number 4. Number 4 is solved. What's the time now? Last one. Already for 50 minutes. All right. Good. So we have one more question left. One more question left. So the last question, question 5, for question 4, find the current through the inductor. All right. If you want to know what is the current through the inductor, I have to refer back to the initial figure that I have right now. So the initial current through the inductor, here as you can see here, it is not only 5S. Yes, 5S is in the initial inductor. Sorry, 5S is the inductor, but don't forget actually the inductor actually both here. Okay, 5S and also minus 1 over S. So it is not only 5S. So if you want to know what is the current through the inductor, if you refer to this figure here, current through the inductor is this one. But we have actually two branches where not only inductor, but we have drawn just now. We also have the initial current, which is come from the inductor as well, which is minus 1 over S. So you have to consider both these two currents. It is actually I2 plus I3. So your current IL is I2 plus I3. So how to solve that? If I want to know what my value, I2 plus I3. Think about that. So I need to know what is my I2. So it is actually, okay, where is I2? We get this. This is I2 and I3 is this. So it is actually this I2 V1 over 5S and my I3 is this one minus 1. That is the I inductor IL. So you should start from there. IL is these two components. All right. V1 over 5S. Remember that V1 over 5S minus 1 over S. Okay, V1 over 5S minus 1 over S. And V1 already known. We already know the value of V1 just now, right? Okay, so we can start from there where my V1 is 40 plus 5S over S plus 1 S plus 2. Okay, we start from there. So my IL, just now we said that it is V1 over 5S and then plus the other current, initial current, which is minus 1 over S. Start from there. So my V1 40 plus 5S over S plus 1 S plus 2. Alright. So my V1 is 40 plus 5S over S plus 1 S plus 2 5S. You see here. Okay. Minus 1 over S. Okay. Can we simplify? What can we simplify here? This 5. Okay, this 5 here can be simplified, isn't it? 5, 5, this becomes 8. Okay, so it becomes 8 plus S over S plus 1, S plus 2, S. S already cancelled, minus 1 over S. Okay, that looks good. So this is equal to, let's say we want to combine the whole thing here. So we are going to have 8 plus S minus S plus 1, S plus 2 over plus 1 plus 2 S. Okay, so this is I, my I inductor, IL in S domain. Okay, so this one, I have to use, I think from here we can use partial fraction extension. We can use partial fraction extension. So make this equal, okay, we bring up here, this equal to A over, first part is A over S plus B over, this is partial fraction extension, B over S plus 1 plus C over S plus 2, which is equal to this. Okay, equal to this. So your A S plus 1 S plus 2 plus BS S plus 2 plus CS S plus 1, this is not new, partial fraction expansion, equal to the above part here, 8 plus S minus S plus 1, S plus 2. That's it. This is the equation. Yeah, I think that's correct. So choose whatever value of S in order to know what is A, B, and C. Number 1, I can choose S equal to 0. So if my S is 0, then here we have 2A. 1, 2, 2A plus, okay, this is gone. Because S0 gone, this is gone. C is gone. So 2, 8, S is gone, minus 2. Okay? 8 minus 2, isn't it? 8 minus 2. So 8 minus 2 is 6. So your A is 6/2 and your A is 3. So I already know the value here where this is actually 3. Okay, and then choose other value as equal to minus 1. Okay, S equal to minus 1 because if I choose S equal to minus 1, A will be gone, C will be gone. What left is B minus 1 plus 2 equal to minus 1. This is gone. 8. Okay, 8 minus 1. 8 minus 1. Because this minus 1 here will be 0. 0 times S plus 2 will be 0. Right? To solve this, 2 minus 1 is 1. Minus B equal to 7. So your B is minus 7. Okay, I already know this is minus 7. Alright? And C. So you can choose one more value. C equal to what value you want to choose? Of course, minus 2. Because A will be gone, B will be gone, then C times minus 2 plus 1 equal to 8 minus 2. Then the other part will be gone. So you have here C minus 2 minus 1, 6. And then your C will be 6/3. Sorry, minus 6/2. So 2, 3. Okay, 3. So C is 3. I know the value is 3. C is 3. So here you can look at here. I think it is not difficult to convert it to time domain because 3/s is 3. Okay? So we write down somewhere here. IL in time domain, 3/s is 3 minus 7 exponential minus c plus 3 exponential minus 2t, and this is all ut, ut, and the unit is ampere, don't forget. So that is the answer. Let's check with 3 minus 7 plus 3 exponential 3 minus. Okay, that's it. Okay, so that's all. What's the time now? Oh, yeah, as I said before, 1 hour, around 1 hour. So you have another 1 hour to solve for assignment. So if you refer to this recording here, I think it will be very clear and you can answer your assignment. So your task now is to do assignment. So let's check where is our assignment. You can go to here, okay, this assignment here. Click this, right, and then you have to click this. Right, let's see. I put it document first. Okay, and then I open. Okay, open that assignment. So please answer question 1, 2, and 3. Alright, it looks familiar. It looks familiar. Try to solve this. And you have to submit today, 15 December. Submit today, 15 December by midnight, before midnight. So it is a group assignment, 3 students per group. Not only calculation, do some brief discussion and also explanation. So if you guys already seen this recording, after you finish, then please go to the link here, okay, link here, the Google form here, to write down your name, your matrix number, and choose your section. All right. This is for attendance today, Wednesday. Okay, Wednesday. Thursday we will do class as usual. But this is offline recording. Hopefully you record your attendance here and do assignment today. Okay, you can start now to do your assignment. All right. Good luck, everybody.